In this objective, we're going to be talking about line and bar graphs. So we're going to start with a line graph. A line graph is what we're going to be using to show change over time. Okay, so we're going to take a look at creating a bar graph first. So the first part about creating a bar graph is creating the different pieces of the graph that we want. So we need to label our graph appropriately. So our data, we want our independent variable x and our dependent variable y. So our independent variable here is our years, right? Different years. So we can go ahead and label this line graph starting at the year 2000. So we're just going to write a break there indicating that this is starting at the year 2000, and I'm going to kind of skip every other just because it's going to make our life a little bit easier when we're plotting it. So we got 2000, then 2001, 2002, so I'll put some little markers where I mean these to be, and then 2003. And we want to be graphing on our y-axis the population of, we're looking at a city here, population of the city. So our data values are, the smallest one is 41,000, the largest one is 46,200. So I want to do another break here because I don't want to start graphing at 0 because that'll take quite a while. I'm going to go ahead and start graphing at 40,000. And I think counting by 1,000s will be fine. So this would then be 42,000. So I'm skipping every other one, save myself a little writing while still giving the person who's reading my graph good information about what's going on. Okay, so when we are graphing this line graph, we're simply going to plot these as if they're coordinate points. You can think about them with a comma in between, in parentheses, and we're plotting it just like any old coordinate point. So the year 2000 with a population of 2,215. And we're going to have to approximate these because it's really hard to get an exact value with our graph the way it is. But we're going to do a good approximation. So in 2001, there was about 41,310. And I just realized I have to change my intervals here. So let me take a moment. I didn't quite write these right. This should be 42,000. There we go. I had missed a couple of zeros on my y-axis. Okay, so then 2001, we got 41,300. So that would be approximately here. 2002, 44,800. Be approximately there, and 2003, 46,200. So a little above 46,000 approximately there. And all we're going to do is connect these points with lines to create our line graph. And you can use a ruler to do that as well to make it clearer. So when we're looking at a line graph, some key points of interest would be the steepness of the line. So if we have a positive slope, that means that we are increasing, right? We're getting bigger. The greater the increase, the greatest increase is going to coordinate with the steepest line, right? The steepest positive slope. Decrease is graphed as a negative slope. So if we look up at our graph that we created, here we have a decrease between the years 2000 and 2001. And the greatest decrease is going to correspond with, so this is the steepest line, we can say going up, right? Because we read a graph from left to right. This is going to be the steepest line going down. Okay. In order to find the change, or the difference, or the change, we're going to use subtraction. So we want to start now looking also at a bar graph. So a bar graph shows a comparison of quantities or amounts. All right, and we're going to create a bar graph for this data set. So just like before, we're going to have two variables. It's less important with a bar graph what goes where, because we don't really know a correlation between, we're not really showing a correlation between these two sets of data in the same way that we were with a line graph. So I'm going to put my teams on my x-axis here, and then I'm going to put the number of points that they achieved on my y-axis. So we don't really have a dependent or independent variable in this specific case of our bar graph. So I have team A, team B, and team C, and I'm going to dedicate two of these columns to each one so that I have a nice and clear bar graph. So our point values, our highest point value is 218. So I know that when I make my y-axis, I need to be able to get up to 218. So I'm going to count by 25. So we always start at 0. And again, I'm skipping every other one, save myself some writing while still telling the person reading my graph what's going on. Okay, so when we draw a bar graph, we're simply going to draw quite literally a bar that shows what value that team has. So team A has 218 points. I'm going to draw a bar up to 218. Now, when you're doing something like this and it's very non-exact, right? If someone's just looking at that bar, they wouldn't be able to tell, is that 218? Is that 220? Because it's not exact up above. So whoever's reading my bar graph can tell exactly what's going on. And then the next one we're looking at is team B, who has 142 points. I actually don't know if they're scoring these points. So just a little under 150, and you can see how this becomes not terribly exact after an amount of time. So I'm going to write the number there just to give myself an idea of what's going on. And then last but not least, we have Team C, who scored 193 points, just hair under 200 there. And we'll fill that in, and I'm going to write that value on top. And there's our bar graph. Okay, so what are some things that we can do with these lines and bar graphs? So the main thing we can do is find a couple pieces of information. We can find the difference between two quantities. So for this, we're going to be using subtraction. Or we could find percent of something. So percent, we take the amount of items divided by the total possible amount, right? Or we often say it's a part over a total. Okay, we're looking, so the part is typically something specific. So we're going to look at a couple of different things, so a line graph and a bar graph, and we're going to reference some information about them. So our first question is asking us, from 2008 to 2012, how much did the family income increase? So in order to do that, we're going to take the difference of those two values. So in 2012, we had about $85,000 in income, and we're going to subtract that because we're doing a difference from 2008, which is $70,000. And we're going to find that they had a difference, and I'm going to use units, of $15,000. Okay. So then we want to see between which 2 years did the income increase the most. So for this, we have to look at our graph a little bit, and we have to identify areas of increase. All right, so on our graph here, we are looking for positive slopes. We can see here in these three sections, we had an increase in income. So from 2000, I don't want my highlighter, from 2009 to 2010, from 2010 to 2011, and from 2011 to 2012. And we want to find which one of these has the greatest increase. So we do have to find the difference for all of these in order to tell, and they are going to be a little bit approximate. So I'm going to go ahead and on my graph write what I think these points are. So this is maybe about 68,000, right? We're not being very specific here. This would be about 45,000. Here we're basically right on 75,000, and we said before that this was 85,000, and we want to find our differences here. All right, so we're going to go ahead and subtract. So 68,000 minus 45,000 for our 2009 to 2010, and then 75,000 minus 68,000. And then for 2011 to 2012, we have 85,000 minus 75,000. All right, so once we do that, we can see that right here from 2009 to 2010 was our greatest increase in income. So we can say that between, we can say 09, we can shorten it, and 10 was the greatest increase. All right, let's look at some more stuff. If the average family income in the township is 71,000, how many years were above average? So this is the average value. They're saying that's most of the time what happens, right? So let's mark that on our graph. Here's about 71,000. And it's saying which years were above that. So we're looking up. So if we look at that, that's our years 2011 and 2012. Okay. So we're going to switch gears now and focus on this bar graph over here, talking about mixed fruit. And we're going to ask a couple of questions about that. Okay. So whenever I look at a bar graph, if there's multiple things represented, I always start by finding the totals of those, because if we saw earlier, we might be looking at some percentages. We might need to look at the totals. So I'm going to first find how many kids there were. So there were 12 here, then another 12, 10, 8, and then this would be about 15. So we're going to add those together and find the total number of kids that were surveyed about their fruit options. And when we add all those together, we get that there were 57 kids surveyed about their fruit options. And I want to do the same thing for adults. So here there were 16, 8, 11, 6, and then 14. And I know that the slash barred bars are kids because I can see that in the little key over here. It tells me, oh, any of the bars that look like that are kids, and any of the bars that were the solid green are adults. And I'm going to add all those together to represent how many adults we have that were surveyed. So that tells me that there were 55 adults surveyed. Okay, so let's go answer a couple of questions now. How many total kids were polled about their favorite fruits? We already looked at how to do that, and we said that there were 57 kids that were surveyed. And how many total people were surveyed? Well, to figure that out, we can take our kids and add in our adults to give us the 112 people that were surveyed. Okay. Now we're going to start talking about some percents. So what percent of the total people polled chose strawberries? So this is telling us that the total that we're looking at is the 112. And the part that we're going to look at is the people that chose strawberries. So we're going to go over here and we're going to find strawberries. And that is looking at this column right here. So 15 kids and 14 adults. So that's for a total of 29. So 29 out of all the people chose strawberries. And we're going to go ahead and actually divide that. So that's 20.25, and I'm going to round to the nearest thousandths place, 9. Now, we want to convert this to a percentage point. So the way we can do that in one of two ways. So first way, we can take 0.259 and multiply it by 100, right? And we get that that's 25.9, and now that's in percent. Or we simply move the decimal point to the right 2 spaces for that 25.9%. Okay. So, next question. How many more adults chose apples than oranges? So we're looking at specifically adults, and we're comparing how many of them chose apples compared to oranges. So again, we're going to find the difference. Because we're dealing with fruit, we're going to take the biggest minus the smallest because we don't want to be talking about choosing negative fruits here. So 16 minus 11 equals 4. So this tells me that 4 more adults chose apples. So apples were the more popular choice by 4 adults. All right. Now it asks us to write a ratio of kids choosing apples, so kids choosing apples, to adults choosing apples. So a ratio we can write in one of two ways, but for our purposes here, we're going to use a specific one. So ratios can be written as a fraction, A over B. They can be written with words, A to B, or they can be written with a semicolon, A colon B. All of these can be read like we had the word, which is A to B. So for us, we're going to use this colon notation, but we're going to reduce it similar to how we would reduce a fraction. So A to B, we're looking at kids choosing apples. So 12 kids chose apples to the 16 adults that chose apples. And we're going to reduce this. So both of these numbers are divisible by 4, which gives us a reduced ratio of 3 to 4.